Hello, good morning. So this class is on Bitg 1233, programming, computer programming, and focusing on the use of C++. So let me share my screen. All right, reduce that and get on with the lecture. So this slide was prepared by Madam Mabliza Ramli from the computer science faculty, and let's get on with it. So the purpose of this being offered this semester is to teach you on computer programs, maybe in general, but the focus is by using C++. Then describe the hardware and software, then to tell you the language of computer, and describe the evolution of programming languages. So a lot of this historical stuff, background of or the progress of in computer programming, and the list of high-level programming languages. So all this interesting stuff or facts that can be shared, or maybe to encourage people to learn a programming language. So because there are a lot of programming languages, when I was a student entering college, we started to learn about Fortran. Then then I had when I went to the States, we used Pascal. Then a little bit of MATLAB when I did my graduate work. At master's level, we use C++ and also some more MATLAB. And I guess even MATLAB is based on C or C++ in the background. Okay, and then learning outcomes, other than what I've spoken, is to learn a little bit about history of C++, and then how to recognize C++ program, explain the different types of programming errors, and then some background on how C++ program is processed and even tested, and then explain what a compiler is, a linker and a loader, okay, and how they work. All right, computer is basically a programmable machine designed to follow instruction. So maybe even our calculators can function a little bit like that, but it's more specific to do calculation only, whereas a computer is more than just doing calculation. Maybe a lot of calculation is done in the background, but computer can display and but in the background, a lot of calculation is being done. But after that, in order for us human users to be able to understand, so a lot of this needs to be displayed to us using the computer, the monitors and whatnot. Okay, and then program is a set of instruction for computer to follow. And because we humans speak a different language than the machine, so the programming language is a way for us to communicate between human and the machine. A programmer is a person who writes instruction, or we call it the program. to make computer perform a test. So without a programmer, no program. Without program, a computer cannot do anything. So computer needs instruction, and that instruction comes from the program. So this simple view of running a program is the instruction, and then we have a bunch of data that needs to be processed. So that's why we need the computer to read the data in a certain way, and how the computer read the data and what to do with the data is done according to the instruction in the program. And then for human users to understand, we need to see the output. Computer is an electronic device with two major components. We have hardware and software. I guess that goes without saying. And hardware refers to the physical parts, the thing that we can touch and have mass. And whereas hardware is a typical computer includes the following. So for the hardware part, we have the main memory, primary storage, internal memory, and then something that we call a central processing unit. Usually if you're talking about the desktop, we have the big box, big black box. So inside it, we could usually call it the CPU, central processing unit. And then we have secondary storage, auxiliary storage, external memory. So those are some additional stuff. We have input devices such as our mouse and keyboard, and maybe even touch screen, and output devices, the screen, the monitor, maybe even printers and plotters. Even if we have speakers, so all those are the output devices. Okay, so that is being shown in this figure. We have even joystick if you are a gamer. So, and we have plotter or a scanner, can also be plugged into other devices. All right, main memory stores instruction and data. Okay, so some are preloaded or being supplied together as they come in the box together with the computer. So these are some of the basic running instruction for the computer. Some are supplied by users, maybe through your own programming. Main memory's content can change during program execution. It is volatile, which means the main memory's content is erased when program terminates or computer is turned off. Okay, that's called volatile. So a lot of things, some depends on whether the computer is on or off. So it is also called random access memory, or RAM. RAM. The other one is ROM, read-only memory, and then we have random access memory, RAM. So main memory consists of long list of memory locations. Each memory location is called a byte, which has 8 bits. Okay, so a byte has 8 bits, binary digits, that contains zeros and one. Binary digit or bit, a digit that can only be 0 or 1. Okay, so a byte will have 8 bits, 8 binary digits, and each of the digit is only either 0 or 1. Okay, so it is shown by this thing. So if Kilobyte means 2 to the power of 10 bytes or 1024. Megabyte has 1024 kilobytes. Okay, kilobyte has 1024 bytes. Gigabyte has 1024 megabyte, and so on and so forth. So, so many as the computer progresses, the size of memory also keep on increasing. Now, I guess if we buy a computer, we are talking about terabyte. Uh, it used to be gigabyte, but now we're talking about terabytes. At least we need 1 terabyte of memory for our computer. Data and instructions or programs are kept in as binary digits in memory locations inside the drive. Each memory location has an address that is unique number of the identities that identifies a memory location. So this is very important. How you can store the data so that you can retrieve it from that location. Some data is too large for a single byte. Most integers and real numbers are too large. Next few consecutive bytes can store the additional bits for a larger data. Address of large data refers to the address of the first byte used by it. So here we have many bytes. So each byte has 8 bits. So in this case, 3 byte location with address number 1. So meaning depending on your size of the information, so you probably have many bytes that is taken to store that data. Then other smaller, a little bit smaller, need only 2 bytes and located at byte this address. So this address is inside the disk memory hard disk or some external disk. Okay, central processing unit, the CPU, is the brain of the computer, or shortly known only by processor. Okay, so this also keeps on changing, keeps on improving. So a CU control unit retrieves, decodes, and executes program instruction from RAM. So that's why we need RAM. So some computers come with 4 megabyte, uh, 8, 16. So we can, the bigger will be the better, especially if you are doing with a lot of graphic work, a lot of calculations. So we need a bigger RAM. So coordinates activities. So a CU coordinate activities of all other parts of the computer. Arithmetic and logic unit, ALU. ALU is a hardware that optimizes for high-speed numerical calculation. So hardware designed for true false, just no precision. So this is designed for very quick calculation processing, and yeah, I guess the computer technology has progressed a lot tremendously over the years, over the decades. And remember when I was in college long time ago, in the 90s, we have 286 computer. I used to have a 286 computer, very old computer and very slow and nothing much for some MATLAB calculation can also take a long time. Maybe you do the uh, programming and run the program, and then go to bed. And hopefully, when you wake up in the morning, next morning, the calculation is ready, and hopefully you get a good result, and the result should better be correct. Otherwise, you have to do run the long calculation again. So that was a very cumbersome situation. And then so CPU, we have the control unit. So in the CPU, we have the CU and also the ALU. So that's the main components in the CPU. So CPU has ALU and also CU. So ALU is for the calculation, and the CU is for a lot of control and retrieving data from RAM and other parts of the computer, other parts of the disk or memories components. Then secondary memory stores instruction and data between sessions. Non-volatile data is preserved when program is not running or computer is turned off. So um, some information is kept. It's called non-volatile, meaning it is even if the computer is turned off, that information still maintained, such as for time. So even if you turn off the computer, when you come back to work, you turn on the computer, it will give you the correct time. So those are non-volatile information. And for secondary storage, there are many types or variety of types, a variety of media that can be used. One is called the magnetic tape, such as floppy disk, hard disk, magnetic tape drive. Okay, and now we have a solid state drive. And then we have optical compact disc, DVD, VCD. You still see those kind of things. Yeah, used to have like this. Students used to hand in their reports and burn the CD. They say it. I'm not sure whether you still do that anymore. And then we have flash memory like USB. So I heard USB was designed by a Malaysian engineer. So that's a very good contribution to the world technology. Then we have input devices. Is how we submit the information to the computer, how information is sent to the computer, so that the computer understands. So input consists of program and data. Okay, program is instruction on how the computer will do the processing, and data is data lah, information that you want to be processed. Some of the examples of input devices include a keyboard, mouse, a scanner, a digital camera. So all the things that we can connect to the computer, a microphone, and I'm also using I'll call that webcam, so can be included, barcode reader, a joystick if you are into game, and also things that might be inside the box, internal, like the HDD, hard disk drive, floppy disk. I don't have floppy disk anymore, but we used to have either 5-inch a long time ago. Back in the 80s, it was 5-inch disk, and then we get smaller to 3.5-inch disk, floppy disk. And then there was the use of magnetic tape. I did not have the opportunity to use that, so that must be so long time ago, maybe in the 60s. And also CD-ROM. So nowadays, if you buy laptop, you don't have that CD-ROM anymore. CD-ROM. So ROM is for read-only memory. So usually for the information in the CD, the computer can only read, but there are some that can read and also write. You can also write on the CD. I mean, write and delete and write. Keep on renewing, such as like you use your USB drive. Okay, and then they will have output devices, and that will include computer monitors, printers, projectors, speakers, headphone like I'm using here, plotters, and also CD-RW, DVD-RW. Okay, so those are things that we see a lot around us. We see on our computer or even laptops. But nowadays, we also have tablets. So tablets, the screen, it doesn't have a separate monitor, but the screen is the output, touch screen. Software refers to program that resides or executes electronically on the hardware. Okay, software is something we do not see, but it is something that we produce or we use. So we have two types of software: system software and also application software. So system software is normally supplied by the manufacturer of the computer. So it comes together when you buy or when you get your computer or tablet. So it's a pre-installed stuff. And this software are needed for the correct running of the machine. This kind of system software manages computer hardware resources and the programs that run on it. So it tells the computer what to run, when to turn on the fan inside the computer, and how to, when the temperature rises, what to do, shut down the computer or something like that. So all this instruction is already preloaded inside the computer. Basic type of system software is BIOS. So maybe you have heard of that. Sometimes you can, when you turn on the computer, you'll see that system BIOS and things like that. Operating system, utility programs, software development tools, and etc. Operating system is the most important type of system, such as in our case, Windows. So Windows is an operating system. Without it, a user cannot run an application program on their computer unless the application program is self-booting. Okay. Okay. So usually for you to install other programs such as C++ or CATIA or AutoCAD, so the computer itself must have this operating system to begin with. So that will be the system that will be a system that governs everything else. So operating system is also a program. So it allows us to communicate with the computer, allocate some computer resources, respond to user requests to run other programs. So it is the background program or the mainstay of the computer lah. So we have different kinds of Windows over the years. Now I guess a lot of the newer computers are running on Windows 11, and if you are on Mac, so they have their own OS, Macintosh OS, run by Apple, and also there is also Linux. Linux is also an operating system, and long time ago when I was a student, we used to have like Sun computers. Uh, in They have a special lab for that, so a lot of this workstation will run on this operating system like Sun, and yeah, maybe there are a bunch of other system, but nowadays the mainstay will be Windows, Microsoft Windows. So a lot for our okay. Yeah, over here we have Windows, Linux, Macintosh, Mac. Now instead of Macintosh, they call Mac, MEC. And yeah, when I first learned about computer in high school, it was DOS. So DOS is pretty much like a blank space with prompt, and you have to know how to find open your directory. So you have to type things like that. So those were before Windows with the icons and things like that. And then you have Unix. Unix is also very popular, especially for science and technology and engineering. And then we have application software, and these are programs that provide services or and problem solution, maybe particular for if you want to do a spreadsheet, you want to do, so there's a program for that, such as Microsoft Excel. If you want to do uh, word processing, so you have Microsoft Word or WordStar, WordPerfect, uh, and things so specific. If you want to do CAD, so you have AutoCAD, CATIA, SolidWorks. So design, an application software is designed to perform a specific task, such as a cost registration system. Like in our case, we have that SMP portal. So, and also there is a general purpose tasks such as word processing, games, and things like that. And a lot of this stuff is you have to pay for it, such as Microsoft Office. So we have to pay for it. But some are free, maybe, and usually the free ones are called open source software. So then we have off-the-shelf software pre-written ready for use, usually for general purpose. We can also have custom-made software written by in-house consulting firm for specific tasks, such as our OBE system, where lecturers, instructors have to key in their marks of the students. So usually that is developed by our computer staff uh, and IT, information technology staff. So they developed this system, but perhaps there are other systems that we can buy off the shelf too. And then customize it for our use in UTEM or in any other organization. Okay. So, yep, that's about it. Where are the application of and system software? Where are the application and system software? So users, then we have application software, and then the application software will interact with the system, so system software. In our case, a lot of us use Windows, or Android. So Android is also a system software. And then we have the hardware. So that will interact with the machine, our computer or desktop. All right. Programs and programming languages. So a computer program is a set of written instruction given to a computer for it to follow. So program is instruction. So understand that. So this is one example of maybe C or C++. So C out, enter the number. So we, as human, we would understand this thing. Enter the number. Okay, C out, of course, of hours work. Enter the number of hours work in hours. Enter the hourly pay rate. So this is to calculate pay, I guess, like salary. But the computer, they don't speak Javanese, they don't speak Malay, they don't speak Mandarin or Cantonese. They speak this low-level machine language. They speak in zeros and ones. Okay, so they don't understand no human languages. So, but we don't understand their language either. So there should be something that will translate so that we, both of us, human and also the machine, will understand each other. So types of programming languages: high level, closer to human language, like the one on the top. Whereas low level, used for communication with computer hardware directly, often written in binary machine codes. So if your programming language is low level, so usually it's harder for us to understand. So you really need to be uh, to be trained in order to be good at understanding or supplying the program, so that uh, the computer can understand. Otherwise, for a lot of us, we will focus on the high level because it is easier for us human to understand. So machine language consists of binary digits or bits. Um, so this one is one example. I don't know what it says there. Okay. History of computer languages. So back in the 40s, I guess back then they use card where they will have holes made into the onto the cards, and then this is supplied to one part of the machine that can read the card. So that's pretty much machine language level. And then we use symbolic languages. Then we start to use, in the 60s, we start to use high level languages like COBOL, I guess. COBOL was some of the earlier languages. Pascal. And then back up until 90s, we start to have natural languages evolving. And so nowadays, with the AI, so I guess we have come a long way to get. So a lot of people just tell the computer, like as if they are speaking to the computer, and the computer can understand through the use of AI. And yep, that is a long evolution. So the only language understood by the computer is the machine language. So at the back of all this progress, uh, the computer still needs to uh, to understand. Or, the computer only understands the machine language. So it's difficult to write unless you are very gifted and trained to do this kind of language. So, but back in the 1940s, as we saw previous slide in the previous slide, we have to speak the machine language. So, to calculate the wage equals to rates times number of hours. So this is how you do it. So 100 100 and so on. And this instruction will load the value. The next instruction will do the multiplication, and then the next one is for storing the result. So definitely it's not something that we can understand. And then we have symbolic or assembly language. Symbolic, and the more commonly used name is the assembly language. Assembly language. I heard assembly language is still difficult. A lot of our friends in the computer science field are still learning assembly language. They still teach that for their undergraduate students in diploma and also degree assembly language. So I have my son also studying computer science. So I think he's also taking this, or maybe he already took assembly language. So it's unique to particular computer. Use mnemonic, mnemonic. So like a silent M in front of mnemonic. So why do we even need a silent letter? But it is what it is in the English language. Uh, Example is mult, M-U-L-T, for multiply. Mult. So the word mult is meaning multiply. Examples of instruction in assembly language and machine language. So in the assembly language, we use instructions such as load. This is 100. 100 is what the machine understands. Store is 1010, and then for multiply is 100 110, and add is 100 101, and subtract is 1011. Okay, so I guess in our this is kind of common, and still is using word that yeah, word that we can understand in our language. So load, store. So this store is like the Malay version of store. So mult, add, and sub is part of the English language, I guess. Using assembly language instructions. So if you want to do this calculation of the wages equals to rates time the number of hours. So for the assembly language, we will type the instruction load. That is the command load rate mult hours, and then we store wages. So wages is the rate. So there's a parameter that's called the rate or variable name called the rate, and there was another variable name called the hours. So we call this rate variable, and then multiply with the hours variable, and then we store that as a wages, then which is another variable. So this must be translated to machine language in zeros and ones for the CPU to execute a program written in an assembly language. Okay, but the language that we want to use in this course is not assembly lah. We are using C++. So assembly language is a totally different language. High-level languages are designed to be easy to read for human. Programmers use this language to write programs. So high-level languages, there are a lot out there. Like I said, I learned Pascal, C++, Fortran, maybe even C, and then MATLAB. And there are others out there like uh, Ada, COBOL, uh, Java, Python. So, but my preference now is still MATLAB. MATLAB, I use that for especially for my doctorate level, doctorate work. And I think possibly in the future we might change from C++ to MATLAB. But it depends. But for now, I guess we still stuck with C++. So that's what we're going to use, maybe starting after the Raya break. Okay, compiler is used to translate a program written in a high-level language to machine language. So compiler is the translator, translator that will enable the computer to understand what we are telling. So we have different compilers that can translate different languages. So maybe for C++ compiler, uh, perhaps you cannot use to compile other languages because each of the high-level language will have different ways to program them. Then we have so I mentioned COBOL and Fortran. Visual Basic is another one. Pascal, C, C++, C Sharp, Java, Lisp, Ada. So these are some of the commonly used high-level languages. Maybe I have to add even MATLAB. MATLAB is also high-level. The equation wages equals to rates times hours can be written in C++ as this one. So it's easier for high-level language. It will be easier. It's simpler for you as long as all these things, the wages, the rate, and also the hours are variables that we create. We can say upah equals to kadar times jam. So we can go in Malay, maybe even Chinese or Tamil, but not sure whether we can use all those other characters. But for what I know, I'm only familiar with the programming using Roman alphabets. Yes. So some well-known high-level programming languages, Basic. I guess when I was in school, we learned Basic. Then Fortran, as I went into maybe second year college, so we learned Fortran. I'm not sure about COBOL. I heard about it, and so it's usually for business. Pascal, when I was in the States, so we used Pascal maybe in my third year. C++ and C++, I think I learned it in graduate level when I was doing my master's. C Sharp is, I'm not familiar with that, but I heard it's much easier from the other two C's. And Java is an object-oriented language. So Visuals, Microsoft. And under Visual, they have a lot of stuff, development stuff that they have, including Visual C++. So so Visual Basic. So this is called Visual Basic. So under Visual Basic, they also have a visual package. They also have C++. But C++ can be also accessed using a lot of other resources. Okay, natural language is like more the human languages, English, French, Chinese, Cantonese, Hokkien, Malay, Javanese, what else? Sundanese. Its use is still quite limited. But nowadays, I guess it's something different now. So if you say prompts in AI, is that considered part of programming? I would say, I would argue, because it is how we interact with the computer. So nowadays, this natural language, natural human languages also can be used for us to interact with the computer, and the computer can give some output based on that interaction. So I would say maybe this is a bit outdated information on this on the slide, but based on the very very fast, or what's the word for it? Very abrupt development in the artificial intelligence. This information needs to be updated. So like human languages can also be not just written on the computer on the screen, but now people can just say the instruction orally, so and the computer can respond to it. So that's how far we have come with computer. Scary. So C++ history, plus in our class, we are going to focus on the use of C++. So C++ evolved from C. Okay, I'm not sure whether I've used C before, but I think C++ is something I use in my graduate work. And then designed by Björn Strustrup at Bell Laboratories. Sounds like a Viking name, Swedish name. beyond iron sight. Beyond iron sight. Yep. It overcame several shortcomings of C. So it is supposed to be an improvement of C. Incorporated object-oriented programming, C remains a subset of C++. C++ programs were not always portable from one computer compiler to another. In mid-1998, the year that I graduated, in December 1997. So, and then during this time, NC/ISO C++ language standards were approved. So there's supposed to be maybe a solution to the compiler so that it can be used in any computer, portable to from one computer to another. Okay, which is good. So NC stands for the American National is NC NC American National Standards Institute, American National Standards Institute, kind of like our SIRIM here, Malaysian Standards SIRIM, SIRIM. And ISO stands for the International Standards Organization. So this is also a good development, was a good development. So this is a simple C++ or a sample C++ program. So usually we include this hatch include IOStream. Hatch include IOStream using namespace std, and you have int main, and then the brackets of bracket, and then we have a curly bracket open, and then return 0, semicolon, and then you close this curly bracket. Okay, so that's pretty much one program in C++. Another example is this one. So hash include IOStream using namespace standard. Okay, so usually you have to use this one. And this is what we have been trained by Madam Marliza. And int main open, and then we have this instruction. So a lot of the main instruction will be between these two curly bracket and also return 0. Okay, so here cout, and then you have this less than, and then you have to have this quotation mark, double quotation mark, and my first this one, so you can write anything between the quotation marks, and then another less than symbol, and then end line, so endl, and a semicolon, no? Semicolon. Then we have cout. So it's pretty much the same thing as the first line, endl. So what the output will be for this one is this one. As you run this program, you'll output this thing shown my first C++ program, which is this one. The sum of 2 and 3 equals 5. Okay. And then 7 plus 8 equals 15. Okay, so it shows that if you have anything you write in between the quotation mark will just be dumped out as the output, whereas this thing 7 plus 8 it'll do the calculation for it. 7 plus 8, and that will be 5. So I mean 15. 7 plus 8 will be 15. So that calculation will be done. Either you give the output, or you calculated it by yourself, or you want the computer to calculate uh, for you. Okay, so that's so actually so this is in chapter slide number 35. So maybe what I'll do is I have downloaded this thing with the help of my friend, Mr. Zairul. Um, this one we can search it, dev C++, dev C++. You can download it, and then you what do you call that? Unpack it. If I'm not mistaken, you need to use certain unzip application. Uh, I will yeah, I forgot what unzip application that is. So let me extract 7-zip. So you have to use 7-zip. So you have to download that if you don't already have that. So you have to unzip, download and install this free free application, free app, 7-zip, and then only you can extract that. Can you extract that without that? Or use the regular extract files? I guess that will also work. But anyway, I already extracted that, and it is here. Yes, this one, the portable one. So the good things, I will share you this one, maybe in the group or WhatsApp, and maybe even in my Ulen. And what you should be doing is to un to open that. You have to unzip it, and then you can start using. And you can store it in your USB drive, your external drive, so that you can bring it to the class when we start meeting, have physical meeting, and face to face in the lab. Or if you want to use your computer, you have your own computer, you can install it on your laptop, or maybe even your what do you call that? I don't know, maybe even your tablet, tablet. So once you get that, you can just click here and get that running. So this is what we're gonna be using. So in our case, source file So this is the source file. Now I can go back to my, so let's see if I can copy this and paste it over here, and perhaps just run this thing, execute, if I can remember how to do it. Save as. You save it to the location that you want. So I'm going to say exercise files. Okay, so maybe store it over here. File one. So let's compile it. And execute this, run. This is run. You can run source files, compile now. See, yes. So see here, it'll give you the output like before. So which is cool. So if I put here, change that a little bit to 2 plus 3, then run this thing. So it will still give you the same answer. All right, so ain't that cool? I guess that's pretty cool. Now let's get back to this. So we can definitely try to run this this sample program. Okay, and then program development. A computer understands a program only if the program is coded in its machine language. We have established that. Programmer, a programmer, or programmers have to write the program and turn it into an executable code, machine language. So such as the portable thing that I click when I want to start C++. So that's executable code. Programmer needs to understand the problem, break into actions, which is writing the program, and then execute the computer, execute by the computer, or get the computer to run the program. Like when I click the run button, and meaning I give the instruction to computer to execute the program. In any program development, the output will only be available if the program does not contain errors. Okay, so that's another problem. Sometimes we give wrong instruction, or the instruction is not according to the rules. So that will give you errors. So types of errors, we have syntax errors, violation of the program and the grammar rules of the language. So we're not talking about the human language here, but the programming language. So that is syntax. Sometimes even a dot or a period or yeah, a nocta is going to give you headache. And usually, like when I hit the run button, so it says you need to compile first. So the compiler is the one who will pretty much check the code line by line before to see whether there is any error or not. All right, and then errors we have runtime errors, error conditions detected with computer at runtime. Yeah, I see this a lot, runtime errors, but I'm not really sure. We get to find more information about what runtime errors are. And then we have logic errors, errors in the program algorithm. And this is very difficult to diagnose. Computer does not recognize this error detected by the programming by checking output of the program. So this is another thing for us engineers, or it doesn't matter lah whether you are engineers or not. But when you use computer, sometimes even without the errors, you will get output, but you have to decide to tell is this output making sense or not. Okay? Maybe there are sometimes something about the output uh, indicates that the answers is wrong. Okay, and there are many reasons for that to happen. Okay, maybe you do like is like us in when we use CAD for analysis. Uh, Sometimes the size of your elements is not small enough, so it doesn't catch certain warnings, or certain calculation might not be accurate because of the size of the element. But the computer will still reveal the result. But you, as an engineer or the end user, should be able to tell that possibly this is not the correct answer. So, but the computer would not know that because it is not in their programming. Maybe it's not smart enough to notice that. But we possibly have that capacity to catch that error. So this is something it's called the logic errors. Might not always be in the capacity of the computer to detect. But syntax errors and runtime errors are basically very common errors, type of errors that we see. And then processing a C++ program from a high level to executable code involves these processes, editing, then to create or edit file containing program with the text editor. So like just now, I just copied that thing from the slide and put in the white space. That white space is pretty much the editor. And then compiling. So when I tell the computer, please execute or run this program, so it is compiling, which is processing. Okay, so it pretty much process the instructions line by line. Um, so it has two separate programs in doing the compiling job. It has a preprocessor and a translator. So preprocessor convert the source file that you just created into directives or instruction, begin with that hash sign, hash include thingy, to source code program statements. Okay, so that hash thing include is also very important because it will refer to certain things like IO stream, input output stream, and perhaps there are other I/O that can be included. And secondly, this translator, like because from high level, it needs to translate uh, into machine language, and also it checks the syntax. The two steps are often performed by the command compile. So we can, instead of go directly to run, can also ask it to do the compiling first. And then if syntax errors are detected, it will prevent the execution of the uh, remaining steps. And then linking, which is run, linker to connect system library, functions code to the object code, producing an executable code performed by command build. Okay, so this is a more advanced topic. Higher language level to an executable code. So we have the person, the programmer, editing in text editor, and then compiling process by the compiler, C++ compiler. So then translate into the machine language, and then linking process by the linker. Uh, the programmer choose build command, so there is the command build, and then we'll create the executable code so that uh, systems library. Okay, so in the program might need some common tools or commonly used operations, such as if we have uh, what call that trigonometry operations, or some optimization or operations. So those needs to be accessed through the use of correct libraries. So if you have a command like sine of 30 degrees, okay, so the computer needs to know what does a sine command mean. So it needs to access to the right library in order for it to understand that command. Okay, so yeah, so perhaps you have to understand this process also for the test, I guess. Program development, continuation from that. Then after that, to produce the output, there are another two processes. Loading loads the executable code into the main memory. So you pass it to the RAM. That's why you need RAM. So if you are dealing with a lot of calculations, so and you are going to need a bigger RAM. So bigger RAM, so it will be much better. Then executing, the last step is to execute the run the program to see the output of the program. Okay, so like previously, I just hit run, and then what it will do is it has to still go through the compiler and also build. Uh, and then do the loading and then also executing. So loading and executing processes are often performed by a single command debug. Debug. So processing a C++ program, so you need a C++ program, editor, preprocessor, compiler, uh, a linker, a loader, and execution. So these are the steps that need to be uh, gone through before you get the output. So, but for what we care is we just take care of this editing part where we do the programming, and then when we hit the run button, we'll do all this in the middle. And what we care next is to see the output. So that is what we can see or control from our end. Integrated Development Environment, or IDEs. IDE is a single software programmer development tool that combines all the tools needed, like text editor, blah blah blah, to write, create, edit, compile, link, load, and whatnot. Examples are for this is Microsoft Visual C++. So that's something that you can download too. So we can use that. You can look for that. Hopefully, you can download it and install for free. And Borland C++, Code Warrior, and we have Dev C++, development C++. So I would suggest we use Dev C++. You can choose for the portable type so that you can install it on your portable USB drives. Okay, so using Visual C++ IDEs, so this is another program that you can use. Include IOStream, blah blah blah. So pretty much what we tried just now. So when you do that, then later you can just go to compiling status. So I usually just hit this run button and be done with it. So you can also go to build and compile. Then linking status. So those are information at the bottom, like what we saw just now. And then this is the result. Start without bugging. So debug will show you this output. This output. Okay, so these are some of the things that you should get from this class or this lecture. List the 5 main components of a computer. I guess you can do that. List the data for a program that adds two numbers. How do we do that? List the data for a program that adds two numbers. Describe the work of a compiler. Define source code. Define object code. Describe the purpose of the operating system. So I guess if in the test or in the final exam, you try to get the answers to this question, I'm pretty sure you can find it in the notes here. And there will be questions such as this in the test or exam, and so just try to study for that. be prepared with this kind of stuff. All right, I guess that's pretty much what we have for this class. I'm gonna stop sharing. So if you have any question, you can get back to me. Otherwise, you folks have a great day. Bye-bye.